Hello everyone, myself Apurva Tanpuri. Today I am going to present my control system simulation. The topic is plotting board diagram, identifying gain margin and phase margin, analysis closed loop stability, and studying the effect of parameters variations using MATLAB. This topic is important because stability analysis is a key requirement. Is a design and control system. So the control system are used to control and regulate the behavior of dynamic system in a application like power system, robotics, and industrial automation. The most important requirement of any control system is stability. An unstable system can lead to oscillation or complete failures. To analyze stability, we use frequency domain techniques such as board plot. These plot help us understand how system gain and phase change with frequency. In this experiment, the system is modeled using the transfer function and MATLAB is used for the simulation and analysis. The main objective of the experiment are to understand frequency response using board plots, to determine gain margin and phase margin, to evaluate the system stability using the parameters, to analyze closed loop response using step response, to study how changing system gain affects stability and performance. The objective help in designing reliable and stable control system. The system is represented using a transfer function, which is mathematical model in the Laplace domain. It defines the relation between input and output of the system. In MATLAB, we define the transfer function using the TF command. This model is the use of generate board plots, step response, and other analysis. The board plot consists of two parts, magnitude plot and phase plot. The magnitude plot show how the gain change with frequency in our system. The magnitude decrease as frequency increase, meaning high frequency signal are attended. The phase plot show how the phase angle change with frequency. It starts around 90 degree and decrease towards minus to 70 degree, indicating the presence of one integrator and two poles. The behavior helps us understanding the dynamic characteristic and stability of the system. Gain margin and phase margin. From the board plot, we determine two important parameters. Gain margin is the amount by which system gain can be increased before the system become unstable. Phase margin. Phase margin is additional phase lag required to make the system unstable. In this system, gain margin is positive and phase margin is also positive. These values indicates that the system is stable and has good robustness. Closed loop closed loop step response. The step response show how the system behaves when the step input is applied. The response rise smoothly and reach steady starters. There is a small overshoot which indicates the system is undamped but stable. The, set, the settling time is moderate, which shows a good balance between speed and stability. This confirms that the system performed well in the time domain. The study parameter variation, the system gain is increased. As gain increase, the system become faster. Rise time decrease. Overshoot increase. Stability margins decrease. This show the increasing gain. This shows the increasing gain improve performance but reduce stability. Therefore, proper gain selection is very important in control system design. In conclusion, the system was successfully analyzed using MATLAB. The board plot provides The blood plot provides insight into frequency response and help calculate gain margin and phase margin. This closed loop step response confirms stable behavior. It was observed that increasing gain improves speed but reduces stability margin. Thus, this experiment demonstrates the importance of stability analysis and the effectiveness of MATLAB in control system design. Thank you.
So hello, I'm Shivam. So we'll see how this code actually works. So the main objectives of these experiments are to analyze the frequency response using board plot to determine the gain margin and phase margin, Also to study the closed loop stability using this step response and to obtain the effect of the varying system gain, also to determine the stability of the systems. So system defines this is our transfer function. Here we defines as g of s is equals to 10 by s into s plus 2 and s plus 5. So this system is a model in MATLAB using this transfer function. So actually this simulation in the MATLAB, I define this transfer function using this ft command and then use the different functions for the analysis. Like a board is for the frequency, margin for the gain and phase margin, feedback for the closed loop system, step for the time response, pole for the check stability, locus for the root locus analysis. So let's run this code for now. So simply we run this code. So after running this code, we'll get these five figures and also here this confidence transfer function with gain margin, phase margin, and here we see that system is fully stable. So we'll see how the load board plot come. So first the board plot is obtained. The margins magnitude plot shows the decreasing trends, which means gain reduces with frequency. The phase starts near about minus 90 degree and goes towards the minus 270 degree, indicating this presence of the our integers and two poles. So this gives an understanding for the system frequency behavior. And another is a gain margin. So here the gain margin and phase margin shown. In this graphs, the gain margin is equal to 16.9 dB at 3.16 radian per second. Phase margin is 55.6 degree at 0.9 second per second. So since both margins are positive and the system is stable and good stability margins. So this means the systems can tolerate gain increases with becoming unstable. So here we see this closed loop response. So next, the closed loop step response is plotted. The output rises the smoothly and reduces steady state. A small overshoot of the system, 10% is observed, and the setting time is around 5 seconds. This confirms that the system is stable and well damped. So stability using these poles shows that the poles are closed loop system are calculated. So the or poles is lie in the left half of the complex plane. Therefore, the system is stable. So this board in this board diagram, you will see that the study of this parameters variation is gain is change is equals to like k is equals to 1, k is equals to 5, k is equals to 10. In this board plot, the magnitude shifted upwards with the increases in the gain. Phase margin remains unchanged. This shows that the increasing gain reduces stability margins. So effect of this gain response is like we will see in this root locus also. So actually the effect of the gain margin step response where k is equals to 1 it shows the slow response but the no overshoot. When k is equals to 5 it shows the fastest response and small overshoot. When k is equals to 10 it vary the response and the higher overshoot. So at the last we will see this our root locus graph. The root locus shows that the poles are moving the gain increases. Our branch moves towards the right and the half plane. This indicates that if gain is too high the system can be become unstable. So we'll see all this final conclusion of this simulation is in conclusion, the system are successfully analyzed using this MATLAB code. Also, the board plotter helped determine the gain margin and phase margin. The closed loop response confirmed the system stability. It was observed that the increasing and gaining improves speed but reduces this stability margins. Therefore, the proper gain selection is important for the stable system. So here we see that our system is stable. That's all. Thank you.